We've got some fresh images of 3I Atlas, a third ever interstellar object.
On the 1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock.
July 1st, 2025. The NASA-funded Atlas telescope in Chile spots something strange, 3I/Atlas, an interstellar body racing into our solar system. At first, it looked like a comet, but when Harvard astronomer Avi Loeb studied the data, troubling questions emerged. How will the scientific world respond? Could this visitor spell danger for humanity? Join us as we discuss the data that left scientists terrified and convinced Avi Loeb that the mass was moving towards Earth. For decades, the National Aeronautics and Space Administration, NASA, has stood as our first line of planetary defense. Through programs like the Planetary Defense Coordination Office, the agency vigilantly scans the skies. They employ a powerful network of ground-based telescopes and space assets to detect and characterize near-Earth objects. Alongside powerful telescopes like Hubble and Gemini South, NASA provides the public with timely updates. They track asteroid belts and share information about any bodies that might wander too close. That way, the public remained informed of any potential hazards. Yet, a shadow of doubt often lingers. Can we always fully adhere to the information provided by such large institutions? History reminds us that there have been instances where information was delayed or carefully managed, often for reasons of national security or to prevent public panic. This historical context is precisely why the announcement from a respected but independent figure like Professor Avi Loeb is so powerful. When a leading astronomer from Harvard University states he has seen something significant, it immediately captures global attention and demands accountability. As soon as the 3I/ATLAS was spotted, Professor Avi realized that it was too bright for an object so far away. He implied that it was about 20 kilometers for the typical albedo of asteroids. This size estimate made no sense to him, since the last interstellar object, 1I/Oumuamua, to have come in view was 200 times smaller. However, NASA, together with most scientists and established institutions, declared their stance on 3I/ATLAS from the start of the discovery. The observations indicated that 3I/ATLAS exhibited all characteristics of a comet. The Hubble Space Telescope, together with the James Webb Space Telescope and Gemini South, observed the growth of a coma, which forms when icy nuclei experience solar heating. Behind the object was a trail of dust and gas that matched the typical behavior of comets. Even the spectral analysis showed the presence of carbon dioxide, carbon monoxide, cyanide, and nickel traces. All these match the patterns of cometary activity. NASA scientists concluded that the object exhibited all characteristics of a comet, so they declared it to be a comet without further discussion. NASA also reminded the public that asteroids made of rock and metal do not create these specific features. The official statement declared that the object presented no danger to Earth. The object followed a predictable solar system path, while its closest Earth approach would occur at 1.8 astronomical units, which equals 170 million miles. The scientific data indicated no reason for concern about this discovery. Avi accepted the comet-like behavior of 3I/ATLAS, but he cautioned scientists against making hasty conclusions. The object displayed an atypical chemical composition which stood out from other known objects. The plume of 3I/ATLAS contained mostly carbon dioxide, with smaller amounts of carbon monoxide and cyanide, but showed minimal iron content. According to Avi, the chemical composition of 3I/ATLAS did not match the typical patterns found in comets. The object's brightness patterns indicated its nucleus size might be smaller than scientists had initially calculated. The true size and structure of the object remained unknown, because most of the observed light appeared to emanate from the surrounding coma, rather than a solid nucleus. However, it was the object's orbital path that spiked his attention. The object followed a hyperbolic path, which meant it was not gravitationally bound to the sun, yet its trajectory seemed unusually precise. The object traveled through the solar system with unusual precision by passing near major planets Mars, Venus, and Jupiter. Avi believed the unusual planetary alignments required additional investigation because they seemed too coincidental.
Professor Avi Loeb and his team say the interstellar object is on an extremely unusual course for a comet that will take it close to Venus, Mars, and Jupiter.
The scientists proposed that 3I-ATLAS could function as an interstellar probe while also potentially deploying smaller devices, which might appear as unidentified anomalous phenomena to human observers. According to him, science should keep an open mind about unexplained phenomena because the data shows irregularities. The disagreement between scientists began when Avi made his statement. Scientists at NASA and other experts responded quickly to defend their position that all of Avi's concerns could be explained through natural cometary processes. Scientists explained to the public that comets exist in various forms. Each comet exists as a unique entity. The brightness of comets varies between different types because their nuclei sizes differ and their chemical compositions produce different plumes. The scientific field of cometary physics recognizes three main phenomena, which include outgassing and dust emission and unpredictable changes in brightness. The scientists explained that the precise orbital path resulted from gravitational forces, which cause predictable planetary deflections of celestial bodies. The researcher stated, "Extraordinary claims need extraordinary evidence to support them," as he repeated a well-known scientific principle. The observed tail and coma, together with chemical signatures, match the typical characteristics of comets. The observed features fail to justify any need for speculation about spacecraft origins. The discussion between scientists shifted to the definition of comets versus asteroids. Scientists in the field of astronomy agree that asteroids and comets have distinct characteristics which distinguish them from one another. The inner solar system produces rocky and metallic asteroids, which stay inactive throughout their existence. The objects cannot create comae or tails. The outer solar system produces icy objects, which scientists classify as comets. The sun's heat causes frozen materials to evaporate, which creates gas and dust streams that generate the spectacular tail effects. Jason Wright, who is an accomplished astronomer, stated that any object displaying a tail should be classified as a comet, but objects without tails remain asteroids. NASA classified 3I/ATLAS as a comet because it met their definition for this category. Avi refused to accept the straightforward classification that NASA and other scientists had established. Nature frequently presents itself through complex categories which scientists need to understand. The scientific community recognizes active asteroids which display cometary behavior and comets that demonstrate unanticipated patterns. The first interstellar object, Oumuamua, demonstrated unexplained acceleration patterns that scientists could not attribute to gravity alone, while showing no tail. The main risk stems from refusing to pose bold questions instead of asking them, according to Avi. The premature assumption of answers leads scientists to miss potentially groundbreaking discoveries which could become the most significant finding of our time. Avi requested that existing space probes like Juno, orbiting Jupiter, and the Mars Reconnaissance Orbiter should observe 3I/ATLAS when it approaches their orbits. The scientists viewed this request as a scientific duty rather than a speculative endeavor. Scientists need to study all observed anomalies through direct observation. The scientific discussion between NASA and OVI intensified during the following months. The object's behavior, according to NASA scientists, stayed within the boundaries of natural phenomena. The observed anomalies in 3I/ATLAS continued to interest Avi. The two groups analyzed identical data, yet they interpreted it through different perspectives. The public witnessed a conflict between official NASA positions and scientific investigation. Media outlets reported on a Harvard professor who opposed NASA's findings, while also covering the space debate about extraterrestrial life. The public was divided into two groups regarding Avi's actions, with some viewing him as a publicity seeker, and others seeing him as a trailblazer who challenged established beliefs. The public received both positive and negative reactions toward his actions. The The scientific community needs both Avi's questioning approach and NASA's methodical approach to validate their findings. Through his dedication, Avi forced NASA and other organizations to demonstrate their evidence more clearly, while defending their methods and explaining their absolute confidence in their classification system to the public. Through his continued investigation, Avi demonstrated to the public that science requires testing all ideas against evidence, regardless of how uncomfortable the process becomes. The scientific evidence collected by telescopes throughout 2025 established a new equilibrium before the comet reached its perihelion in October. The coma grew to its predicted dimensions. The tail illumination followed the predictions of volatile substance emission models. The object's composition displayed unusual patterns, which scientists identified as belonging to infrequent cometary types. The object demonstrated its natural behavior through a series of sequential observations. The evidence against an artificial origin became impossible to deny when the object reached its closest point to Mars on the 3rd of October. The majority of scientists now accept that 3I-ATLAS functions as an interstellar comet, which follows natural comet behavior patterns. The data showed no evidence of artificial origin, so Avi maintained his stance while confirming Earth faced no danger. The investigation failed to prove alien technology, but demonstrated how essential it is to maintain open investigation of all possible scientific explanations. 12 days after the 3I/ATLAS was discovered, Avi released another document on his Medium page. In this document, he acknowledged that preprints reported that the masses observed spectrum does not show the spectral fingerprints of atomic or molecular gas. Instead, the spectrum only showed evidence for reddening of reflected sunlight. Finally, Avi accepted that the mass was a comet and decided that the reason the spectral features of its gaseous coma were missing was due to its great distance from Earth. However, he stated that if future data indicates the absence of a cometary tail, then it would mean something new and perhaps more scary. Avi said that it meant the comet didn't inherit a random velocity in space, but instead was sent towards the inner solar system by design. That would mean a possible threat in the future, but for now, the immediate threat had vanished and normalcy returned. But what if it was really a comet headed for Earth? Or worse, if it were an asteroid? If a comet hit Earth, it would be one of the worst disasters ever. How bad it would be depends on how big the comet is, what it is made of, how fast it is going, and where it hits. A small comet that is less than 100 meters across would cause damage in one area. The hit would be as powerful as many nuclear bombs. It would create a huge shock wave and extreme heat. If it landed in the ocean, it would cause giant waves called tsunamis. In 1908, a small object hit Siberia and destroyed a huge forest. If this happened today over a city, it would be terrible, but it would not destroy the whole world. A medium comet between 500 meters and 1 kilometer across would cause worldwide damage. The hit would make a crater many kilometers wide. It would destroy everything nearby. It could cause earthquakes and huge fires. If it hit the ocean, it would create tsunamis hundreds of meters high that would flood coasts everywhere. The biggest problem would be after the hit. The crash would throw dust and ash high into the sky. This would block the sun for months or years. The whole planet would get much colder. This is called an impact winter. Plants would not get enough sun to grow. Animals would starve. Farming would stop, and people would run out of food. Many types of plants and animals would die out. A large comet, over 5 kilometers across, could wipe out most life on Earth. This is what happened 66 million years ago when the dinosaurs died. The immediate hit would cause huge firestorms and superheated air. The impact winter would be very long and cold. Acid rain would poison the land and water. It is unlikely that every living thing would die, as some very small life forms might survive. But human civilization would probably end, and it would take millions of years for life to recover. In short, a small comet hit would be a regional disaster. A large comet hit would be a global catastrophe that could end the world as we know it. For now, the cosmic calm returns. 3I/ATLAS recedes into the interstellar dark. Its mystery unresolved, but its threat neutralized. The debates fall silent, and we are left with the unsettling aftertaste of a test we passed. The void is vast and ancient, and this was but a single warning shot across our bow. An unanswerable question remains. How long until the next one arrives? And will we be watching closely enough, or will it come without any warning at all? Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.